And welcome to 90 Notes, the iSchool version. Well, during this pandemic, we're doing these classes online, as you know, and this has got to be the funnest quiz. Couldn't resist making a little video on this one. 805 there, 3D, mostly visualization. Now, if we were in the classroom, we would be doing this with we'd be learning a new piece of software called Google Sketchup. So I'll show you what you're going to miss. Bummer. There's 5 descriptions here, text descriptions, and you're supposed to be matching them with these 5 words, I guess. And you might be getting different ones because well, this is a sample, so let's just go through it. We'll go through these 5 shapes. We're going to draw them in Google SketchUp. So let's start with the first one. Well, in the first one, I've got a cylinder, and you can see the cylinder, and I'm putting a plane through it. Now, perpendicular, I'm guessing they mean perpendicular in this direction. If you put it the other way, clearly you'd get a circle if you cut the cutting plane the other way. But this is a cutting plane. All you in the engineering house know that. So you can see clearly it's going to chop out the shape here, and what would be left would be well, you figure that out. I think you can all see that. All right. Okay, so you got yourself a rectangle. Let's look at another one. Let's look at, what shape is created? Now, you've seen this question probably a dozen times, and this would be a lot of fun in the lab. But and you can get Google SketchUp, download a free copy or a student copy. It's really fun. So I've got a triangle, and it says rotated about the y-axis. Pretty presumptuous of the author to say, well, who's to say that one of the legs was on the y-axis? That would really ruin it. So we're just going to take this thing and we're going to spin it around like that. So we're going to revolve it. And that circle was its path to trace around the floor, because you're going to know in your future classes that this cone is a solid of revolution, which is kind of fun, isn't it? Okay, well, that's 2 down. This is really fast. And this is the one that I got a little trouble with, the way your author says this. Perpendicular cross-section of a pyramid. Well, first off, didn't say specifically it was a square pyramid or what other kind of pyramid it could have been, but I just gave you 2 different possibilities here. I put a cutting plane, revolves over here. I put a cutting plane this way, and you see clearly if I chop this out, I'm going to expose, well, you can see that. You can see a triangle right there. However, let's suppose I put the cutting plane this way. Can you see what shape you've cut out there? I'm going to chop through like this. Now that's still perpendicular, well, in my book. And that's still perpendicular, and that's clearly going to cut out a trapezoid. It's going to happen to be an isosceles trapezoid because this pyramid is regular. It didn't say that it had to be a regular pyramid either. So there's a lot of holes in this, I guess, in this line of questioning, but you can see it maybe a little differently there. So again, 2 potential examples, but I think they only gave you 1 of those as your choices. So again, we made some assumptions. In this case, we made a square pyramid, and we made it a regular square pyramid, not oblique, meaning the vertex is directly over the center of the square. So that one was the one I had the most fun drawing. And all right, well, enough of that. Let's look at some other stuff. And the parallel cross section of a sphere. Well, I got myself a little sphere here, and I made the center of the sphere the origin of the 3 axes, 0, 0, 0, as it were. Some of you are probably noticing that this doesn't even look like these arcs look like polygons. And well, that's how most of your 3D solid modeling software looks. We're still working towards that perfection. But clearly, what you got there, you cut that thing in half. You could have passed the plane up You could have cut the plane through somewhere other than the center, but you'd still get the same shape. And you all can see that. It is a circle. Okay, good job. Let's see, we've got one more before we move on. And this is what happens when we take a rectangle and we revolve it around the y-axis. Again, it was very presumptuous of the author that one of the sides of the rectangle was actually on the y-axis. We'll just play along because we know they meant well. So I'm going to take my little follow along tool. The red thing is the rectangle, and this green axis is the y-axis. Oh, and by the way, the blue axis, you'll notice that's the 3D axis. If you were to, those of you in physics probably know the right-hand screw rule. If you point your fingers in the direction of red, positive x, and you curl them towards green, positive y, your thumb is going to point, using your right hand, your thumb is going to point in the positive z, or in this case, the blue axis. Well, a little bit for your physics class. So here we go. Let's take the solid and we're going to revolve it, boom, around its circular path. And of course, what you are going to generate is a cylinder. Because you know that a cylinder, or in this case, is also, interesting thing about the cylinder, we can achieve a cylinder through extrusion, but we can also achieve it through this solid modeling process. And let me just demonstrate extrusion, just in case we've forgotten, for comparison's sake. Oops, let's get, I guess my circle's busted. Let's get rid of that one and we'll just make a new one. So the other one was by, oh, it's in the wrong plane. Doggone it. Sorry about this. I'm going to have to change planes now. If I were to take this circle, and where's my colors? I'm going to take this circle, and then I'm going to move this around a little bit so that the blue is the vertical plane. So now I'm looking at x and y. X, y, see again, x, y, positive z is in the blue. This is the way it's normally oriented, but I was trying to be consistent with your author there. And if I were to take this and pull it, that's an extrusion. And you see that is probably the more simple way to generate a cylinder. So either way, you can revolve it, you can extrude it. It's kind of fun. Okay, we've just got a little bit more to go, and then we're finished. We're going to go to, so you hope you all match all those up. And the next thing we're going to do, you're going to have to type something in, so be careful. That I can't help you with. I can help you with the visual, and they are asking you, what happens if you pass a plane through a square pyramid, a parallel plane? Now I'm thinking they must mean parallel to the base, even though I didn't think that was explicitly said. And here you can see very clearly what kind of shape you get, and you're going to have to write that word in. Trust me, I don't know how this works. It's not my software. But look at that. You can see the cutting plane is the blue, and it's passing through that pyramid. And if we were using our textbook, we would have this great problem, and we'd be using similar shapes because, of course, regardless of the shape of this pyramid, it could be pentagonal or hexagonal, the cutting plane would render us a similar shape to the base. So again, that would be a case for your similar polygons. In this particular case, I think it's pretty obvious what it is. You can see it right there. Okay. All right. Well, that was fun. I wish you guys were still in school so we could actually be making these models rather than talking about them. But, if you're bored, tell you what, go ahead and download this program for free. See if you can make that and send it to me. That'll be fun. And, all right, one more. And Now this one, yeah, this one's a little odd. Um, and again, I'm orienting the axes where blue is, well, red is X and green is the Y, and Z is coming out towards me. Um, you can all see what that shape is. It's clearly a semicircle, and I put it entirely inside the first quadrant. So the coordinates, again, the coordinates there are 0, 0, 0. The coordinates up here, I think it's got a diameter of 10 meters. That anybody know what those? That would be 0, 10, 0 would be those coordinates. A little bit of 3D trivia. So let's do this. Edit, redo circle. I'm just going to put this circle in because this circle is the path. And whenever I spin it, I want a little color on that. So I'm going to grab this circle and I'm going to revolve it. And let's see, what shape exists in a quadrant 1 if only on a coordinate? Yeah, if you can rotate it into a sphere. Well, clearly, if we're going to rotate this thing into a sphere, the red thing is a semicircle. So let's actually do it. We take this and we spin it around, and there we go. We got ourselves our sphere. We did our sphere, and we revolved that semicircle around a circular path. Well, hey everyone, that's it. I think you all probably aced this quiz anyway because it was pretty straightforward. But I just wanted to have some fun with the drawings. So so everyone, stay well and keep in touch. And thank you for watching Nani Notes.